Right, so in this video we're going to go ahead and just give a little bit of terminology of some things that we're going to be using quite a bit in the next couple of sections, and that is some just kind of definitions of different types of statements. All of these are going to revolve around this kind of initially starting with some conditional statement, because conditional statements are going to become some of the most important statements that we use throughout the entire course, these kind of classic if-then statements. So if you give me a classic if-then statement, one of these things of the form P implies Q, I'm going to refer to the converse of this thing as the statement where I flip the order of these things. That is, if I start with P implies Q, the converse is then going to be the statement Q implies P. The giant, huge, important thing that I'm going to circle a bunch is that the converse is not logically equivalent to the original. And we alluded to this a little bit already. It's this idea that if we have the statement that says, if Jeff owns a board game store, then Jeff likes playing board games. If that's my original statement, the converse of that thing would say, if Jeff likes playing board games, then Jeff owns a board game store. And that's not necessarily the same as the original statement. So that's going to be a huge thing to note, is that those two things are not logically equivalent. Sometimes when we're working with some of these biconditional things, we do have that P if and only if Q, so there's going to be some kind of weirdnesses that come up. But the big thing to note is that classically the converse is not logically equivalent to the original. If it helps, like I said, to always come up with one of these cheesy little examples of kind of thinking if A implies B, and then you can quickly say, well, does B imply A? The answer is most of the time, no. So in this case, that is the converse, is when I flip those things around. The thing that does allow us to flip and keep equivalence is that if I flip as well as negate both of those two things, then I will in fact keep this idea of being logically equivalent. And that's exactly what this contrapositive is going to say. If you start with your conditional statement P implies Q, the contrapositive of this thing is still going to have this switching happening, except for both of those things are going to pick up negations. So if I start with P implies Q, the contrapositive of this thing is going to be not Q implies not P. And the thing for this is that the contrapositive is logically equivalent, and it becomes a very slick trick for trying to show various forms of equivalences. Sometimes the classic kind of starting statement P implies Q is going to be hard to work with, but working with not Q implies not P is going to be something much easier to work with. Lots of times when you have lots of negatives and things like that going around, this ability is going to become pretty slick. Okay, so let's just dive into a few examples where we're actually going to go ahead and try to write some converses of some of these things. Rather than constantly chatting about Jeff and his board games, we can switch up examples just a little bit. So the first example is going to say, if it is raining outside, then I will carry my umbrella. So hopefully when you see this thing right away, you see this giant if-then structure. So it's saying, hey, this thing is properly a conditional statement. I'm going to have my it is raining outside is going to be my hypothesis in this thing, and the idea that I can carry my umbrella is going to be my conclusion. If it's raining, then I go ahead and grab my umbrella. So the structure of this thing is going to be P implies Q. So it's easy enough. So the converse of this thing is going to be the flipped version of this thing. It's going to be Q implies P. And if I try to write this thing out, it's just going to simply say, if I carry my umbrella. So there's my switched version. I'm starting with statement Q. So if I carry my umbrella, then it is raining. Let's kind of sketch it at that point in time. So that's the idea. You're just going to flip these two things around, change the order, and you can see that this new thing that I just created is not going to be saying the exact same thing that I started with. The first one is this kind of, if it's raining, then I carry my umbrella. The idea that just carrying your umbrella is not going to guarantee that it's going to become raining. You could maybe just carry your umbrella for any particular reason. It's this idea that if it's raining, then you'll carry your umbrella. The other direction does not hold. So the second one is where we start to bring in a little bit of math. It's this idea that if P is a prime number and greater than 2, then P is going to be odd. So there's a couple ways you can attack this thing. On one side, you could say the left-hand side of this thing is actually separated by an and. So you could actually have two little statements floating around. It's still going to be a giant if-then structure. So you could either say that entire left-hand thing is going to be your statement P, and then you're going to flip it around. Or you can say that maybe P being a prime number is going to be one statement, and the idea that you're greater than 2, I put that box around the wrong thing, there we go, around the then, not the than, and being greater than 2 in this case could be two separate little statements, and then the third one could be the fact that P is odd. So if this is my statement A, this is my statement B, and that's my statement C. My overall statement is then of the form A and B is going to imply C. So if I flip this thing around, my contrapositive is going to be of the form C implies A and B. All I'm doing is just taking my hypothesis, which is then going to become my conclusion, and vice versa. My conclusion now becomes my hypothesis. So if I were to write this thing out in words, which I'm not going to right now, I'll just kind of say it. It's the idea that if P is odd, then P is a prime number and P is greater than 2. So that's the idea. You're just basically taking this part, copying and pasting, and flipping those two things around. So the converse is very easy to work with. All you're doing is just picking up, swapping the order of those things. But the thing to note is that these new things that you're creating are not logically equivalent to the original. If I want to switch things up and start looking at the contrapositive of some of these things, then we're going to see some things that are in fact going to be logically equivalent. So this first thing is going to be this idea that I already identified this as being a P implies Q. So here's my P, here's my Q. The contrapositive of this thing is going to say, okay, flip those things around, but also pick up these negations. So when I write this thing down, I'm going to have if the negation of Q. So that's going to say something about not carrying your umbrella. So if I am not carrying my umbrella, so if I am not carrying my umbrella, so that's my negation of my kind of Q in this case. What's going to happen is that I'm then going to have the negation of P. So then the negation of P is going to say something about that it's not raining outside. So I'm just going to say then it is not raining outside. And that's it. All you got to do is just flip these things around, throw in a couple words not, and then you have your contrapositive. So in that case, that thing is saying the exact same thing. So if you happen to see me and I'm not carrying my umbrella, well then you know that it must not be raining, because every time it's raining, I will be having my umbrella. So if I'm not carrying my umbrella, then I know that it's not raining outside. So you can see that those two statements are in fact logically equivalent. They are saying the exact same thing, just worded slightly differently. So the next one, if we start to manipulate this a little bit, you can see that I did classically structure this as this is my statement A, this is my statement B, and then here's my statement C. They are separated by this if-then structure. So it looked like A and B, and that's going to imply my C. So if I try to think about the contrapositive of this thing, here's where some things are going to change a little bit. It's going to be this idea that I'm going to have not C is going to imply the negation of the statement A and B. So if you go back to this thing and try to think about writing this out, what it's going to say is if P is not odd, then what's going to happen? You're going to have that it's not the case of all of this stuff occurring. So I'm not going to have that P is a prime number and greater than 2. So now you want to step back and think a little bit about what does that actually mean? This idea of if I'm not a prime number and I'm not greater than 2 in this case, what's happening? Well, if you're not a prime number, you could be composite. And if you're not greater than 2, well, then you're going to be less than or equal to 2. But in this case, if I'm not both of those things, I just have to fail at being one of them. So there's this or coming into play. There's a weird little switch up actually happening. And that's actually going to be a huge, huge result, which is going to be referred to as De Morgan's. We alluded to it a little bit earlier. On the next little bit, we're actually going to properly state this thing. It's this idea that if you have this negation of A and B, what that's going to kick out is a negation of A or the negation of B. So in this case, my contrapositive is going to have another form. I can either write it like this or I can write it like this. So this is kind of version 1 and this is going to be version 2, and those two things are actually going to be logically equivalent. And it becomes a little bit nicer when you write that second one. Writing it with an or, kind of having the negations on individual objects is much easier to kind of state in a kind of dialogue than it is to have this. It is not the case that P is a prime number and greater than 2. So let's go ahead and actually try to write this thing out. So what's going to happen is if P is odd, so the negation of that thing is going to say, well, if P is not odd, that's going to say that P happens to be even. I think earlier I might have said this about being prime, but for now, it's the idea that P is odd. So my statement is going to say not C. So if P is even, then what's going to happen is I'm going to have the negation of A. So it's going to say P is, so the negation of being prime, that's where the composite's going to come into play. If I'm not prime, I'm going to have composite. So P is composite. Or the other case could be I am not greater than 2. So I'm going to say or P is less than or equal to 2. So those are my two options. In this case, if P is even, then P is going to be composite, or P is going to be less than or equal to 2. That's going to say the exact same thing as the initial statement that I had, this idea that if P is a prime number and greater than 2, then I must have that P is odd, which you can kind of go back and think a little bit about what these prime numbers all look like. They all actually are odd numbers, except for that weird case of being 2. So then the idea is that if you hand me some even number, well, the case is either going to be that P is going to be some composite number, sure, fine, or I might have the special case that P is less than or equal to 2. So that's kind of the equivalent version to say the exact same thing. Both of these are going to have advantages and disadvantages. Sometimes working with these even numbers is going to be easier than working with a prime number and numbers that are greater than 2, and vice versa. You get a little bit of kind of back and forth on some of these things. So for now, it's just a little bit of practice of trying to rewrite these converses and contrapositives in slightly different ways. The big thing that's coming into play here is going to be this De Morgan's, and we're going to now see that formally.